Hello everyone, welcome to CC320. In today's topic, we are going to cover network models. Before talking about network models, first we need to understand what is a network. We can say a network is or it consists of some hardwares and softwares. So basically we can say there are some devices such as computers or mobile phones that are connected together, which have some softwares that facilitate them to do communication between them, and the whole communication will be done using the network model concept. To understand the network models, we must understand the concept of layers. So to visualize what is uh, the layering task or what is the concept of layers, we are going to consider a very simple example where two friends will exchange information between them using a postal mail. So let's take a look to the example. Let's see an example of a real world to understand the layer concept. So the example is basically the sending a letter from a friend to another friend. So let's take a look to this example. Let's consider a boy is sending a letter to this girl. So how the process is done from sending the letter till the receiver gets the letter. So here we have to consider three terms basically. So the first one is the sender, which is the boy here, and the second one is the receiver, which is the girl here. Then we will have a carrier that I'm going to show you in the overall process. So the first steps from this sending a letter is the boy should write the letter first, and he should put it in an envelope. After putting it in envelope, the letter should be put in a mailbox. From this mailbox, a postman will collect this letter and he will deliver it to the post office. From the post office, the letter will be carried out using a mail truck, or it can be a bicycle or any mode of transportation that the post office has, to send the letter to the post office that belongs to the city where the girl resides. From the post office, a postman will be given the letter, who will deliver it to the mailbox of the girl. From the mailbox, the girl will receive the letter and he can read it after opening the envelope. So this is the overall process of sending the letter from one friend to another. I have already mentioned that we have three things. One is a sender, another is a receiver, and the last one will be the carrier. Here the carrier is basically the mail truck that is shown between the post offices. All those steps are involved just to send a simple letter. So if we consider these steps are the layers of sending a letter, we can see that the first step will be the boy posting the letter to the mailbox. The second step can be considered as the postman delivering the letter to the post office, and the third step will be considered the post office given to the mail truck the letter, which is considered the transmission media here. And lastly, the receiver side will be doing the same steps that we have done in the sender part to get it to the receiver. So here the layers are very clear in this example. Let's take a look to in details information that is shown in this figure. So here is the detailed information, and with the sender and receiver showing the letters, we have three layers involved. The higher layers are those layers or the steps that are involved in order to sending the letter, just to write it and drop it in the mailbox from the sender side, and from the receiver side is picking up the letter and reading it. The middle layers can be considered the postman collecting the letters from the post office, and the lower layers, or we can say the layers that are invisible to us, is basically the post office delivering the letter from one to another post office. So this is basically the tasks that are involved in order to send a letter. And in data communications, we have this kind of similar layer concept. What we are going to do is basically, when a device is sending some information to another device, it can be a mail, it can be a phone call, or anything kind of that, where two devices are communicating, we are going to divide this communication in several steps. These steps will be involving different layers in the communication. Here is basically the concept how the layering makes the communication task divided in different layers. So here we have the layer 1. Layer 1 will do some kind of activities and will generate some information that will be given to layer 2, which will do another activities using the layer 1 information and give it to layer 3. Layer 3 will again do some activities and some actions, and if there are more layers will be given to layer 4, or otherwise layer 3 will be the end of the communication. So let's take a look to another example where some layers are involved, where we are calling a friend. For example, uh, this person is calling this person. So which layers are involved in this communication? The first layer is the content layer. This is basically what kind of information they are asking. For example, this person is asking, where is the cafe? The second layer that is involved in this communication is the rules layer. What I'm referring as a rules layer. So basically rules layer is kind of common rules that both sender and receiver should have. For example, they should speak in the same language. This is one of the protocol or conversation rules that we can consider. If the two friends or two persons don't understand the language, the communication will be not effective. For example, if this person is talking or is communicating using Chinese, and this person does not understand Chinese, so he won't be able to understand what he is saying. Therefore, we need to use a common language, and this can be considered as a rule. The second rule here is basically wait your turn. In a normal communication, or when we communicate from in a person to another, we basically wait for our turn. If a person is speaking, we should wait before we can speak, right? So here also it is considering as a rule for communication. And the last rule is wait till the signal is finished. So basically, if we are talking in a call or we are using a mobile phone, so we need to wait till the phone is disconnected. So these are basically the rules here that we have in this communication. And lastly, the two persons here will be considered as a physical layer. So in this whole communication, we have three layers: content layer, rules layer, and physical layer. And overall, in data communication, we will have these particular layers that I'm going to show you in the next slide. So what are the benefits of using this layer? So basically, uh, the layer model or this kind of layering steps make us easier to find any kind of fault that might happen. If in the example that I have shown previous, for example, the language, if it is a barrier, so we can easily identify what was the problem. The problem was in the rule layer, right? So this is one of the benefits of a layering model. Another benefit is that we can change any layer without affecting another. So in our rules layer, if we change the language to Chinese to English, then the friend will communicate easily and the message or anything that need not to be affected, right? So this is another benefit of layering model. And the last benefit is that we can have defined information that they act upon. So basically they are independent even though they use the information given from the layers, but we can consider they have defined information so that they can work alone. Okay, so basically the rules or the loose layers that are involved in the communication is known as protocol. So we can say protocol is basically some set of rules which defines what we need to communicate, how we need to communicate, and when we should communicate. All this set of rules are known as protocols. Okay, here in the blue marked one is showing these are the protocols of this communication. So basically protocols will describe processes such as the format or a structure of the message. This is basically what we are going to send. Also it's going to show or give or define the method by which the networking devices will share their information. Also the path they should take when they are sending the information. This is basically the how. And next it should define also if there are any error type of uh, things that are involved in the communication, which is how and when. And lastly, it will also define how the starting and termination of the communication should do. This is overall how the protocol should be defined involving all this concept. Now we are going to talk about standards, or what are the standard organization. We already have talked about protocols, which are the rules that are involved in data communications. Standards can be said These are protocols that are approved by some organizations. For example, we can consider the laws that are approved by a government as an example of a standard. If we consider in the perspective of Bangladesh, we have some rules or some laws that are approved by the government in order to have a order in the society, right? So standards are kind of protocols or the rules that are approved by standard organizations in order to have a successful communication. So not all protocols are considered as standards. Same as not all rules are approved by the government, right? So some laws or some rules are approved and others are existing but not approved. Still they are rules, right? So there are two type of categories that the standards are divided. The first one is the factor standard. The factor standard means the standards or the rules that are not approved by an organization body or any particular standard organizations. However, these standards or these rules are so popular that they have become as standards. So according to this category, we will have a different type of model then we are going to talk about later. And there is the jure standards. The jure is basically the opposite of the factor. The jure standards are adopted or they are defined by a officially standard organization. So it's basically we can say the factor are basically the rules that are not being or not have been defined by the organization body, but they became so popular and so the persons or the peoples are using too much that they have considered as a standard. And the GEOR are the standards that are already been approved by some kind of organizations. So according to this categories of standards, we are going to have two different models in networking, and we are going to see in our next part what are these kind of models. Okay, so here is basically saying the same thing. The standards are basically protocols and agreements that are widely used and accepted. So here is showing the standard is basically wait for 2 full seconds to signal stopped. So this is a rule that we need to wait till 2 seconds in order to understand that signal has finished. Some standard organization examples are given here. For example, we have the International Organization for Standardization, known as ISO, and then we have Institute of Electrical and Electronic Engineers, which is IEEE. These are some organization they which makes the rules on the standards for data communications. Now that we can understand what is layer, we can take a look to two different models. The first one is OSI reference model and the second one is TCP IP model. OSI model is a model that follow the standards that are written as DGO, and TCP IP model is involved the factor standards. So basically OSI is the reference model that has been approved by an organization using their standard rules. And TCP/IP model is a model that have been approved by this organization, but the rules that they follow um, has been adopted because of the popularity and not because it was already defined or approved standards. Okay, so let's talk about the OSI model, which is our reference model. This model was given by or approved by ISO in 1947. OSI model in terms of meaning is basically refers to open system interconnection and was introduced in 1970s. This model has a layered architecture itself, and it will have a process of encapsulation and will involve peer-to-peer processing. We'll learn all about this in our next lectures. So let's take a look to this model first. We have already said that ISO is the organization who approved this OSI model. The OSI model involves 7 different layers, which is shown here. The first layer is the physical layer, which basically will dedicate in the conversion of signals to binary data. Then we have the data link layer. Here we will talk about the MAC address or how the MAC is required in these layers to achieve the communication. Then we have the network layer. In this layer we will talk about different devices, hop to hop connection. We'll talk about IP addresses. In the fourth layer we will talk about different type of protocols such as TCP, UDP, how the communication is done, what is segments, and so on. In the fifth layer, which is the session layer, we'll talk about different kind of synchronization, logging, and so on. In the presentation layer, we will talk about encryption, comprehension type of task, and lastly the application layer. Here we'll talk about protocols such as HTTP, the mail interfaces such as Gmail. Okay, so this is more or less a overview of the OSI model. We will talk about in details of each of the layers in our next discussion. Okay, so basically this is one of the configuration or one of one of the ways to remember these 7 layers, because in our next topics all the things will be involved or will be around this functionalities of these layers. So to remember these layers or this model, we can remember this sentence: all people seem to need data processing. So from all we have the A for application, then from people we have P for presentation, SIM we have S for session, then we have T as transport layer, then N for network, then we have D for data link layer, and lastly we have P for referring to the physical layer. So these 2 layers, the first and second layer, physical and data link layer, are basically concerned how the data is moving through the network or from the devices one to another. And the above layers 3 to 7 are basically concerned in terms of applications. So this is basically more or less in software side, and these 2 are basically hardware side. We'll talk about all of this. Lastly, in this uh, lecture, we are going to talk about TCP/IP model. So, TCP/IP model has the same functionalities that OSI model has, but it's a little bit different in terms of organizing the layers. The OSI model consists of 7 layers, whereas the TCP/IP model is consist of 4 layers only. So in these layers, how they are actually doing the functionalities. The functionalities that OSI model do in application, presentation and session layer, in TCP/IP model, all these layer tasks are done in only one layer, which is the application layer. The transport layer, the functionalities of transport layer are done exactly same in both model, and the name of the layers are the same. The network layer functionalities of the OSI model is done by the internet layer in the TCP/IP model, and the layers that are data linked and physical in the OSI model are done in the network access layers of the TCP/IP model. So here there is a combination of layers in the TCP/IP model, whereas in OSI model they have different functionalities according to the layers. So TCP/IP model is basically a more complex approach in order that they are actually implementing 3 layer steps in a single one, like application layer, or similarly of the network access layer, which is involving 2 layers functionalities in only one. uh, However, there are some usability of both, and we are going to talk about the reference model in our next lectures. Thank you.